Japan is preparing for a future where millions of intelligent robots work inside factories, hospitals, shipyards, restaurants, warehouses, and nursing homes. But before those machines can move safely through the real world, Japan believes it needs something far more important than the robots themselves. It needs a national AI brain powerful enough to train them. That is the mission behind Noetra, a new government-backed company supported by some of Japan's biggest industrial names. The project brings together companies including SoftBank, Honda, Sony, NEC, and dozens of other partners. Its goal is to develop advanced physical AI, artificial intelligence that does not just generate text or images, but understands objects, movement, space, and the consequences of real-world actions. Noetra's chief executive has described the project as Japan's last chance to strengthen its domestic control over critical technology. That statement sounds dramatic, but it reflects a serious concern. Japan remains one of the world's strongest manufacturing nations, yet the most important layers of modern artificial intelligence are increasingly controlled by companies in the United States and China. The leading AI models, cloud platforms, data centers, and advanced chips are concentrated in a small number of foreign companies. Japan builds cars, cameras, industrial machines, sensors, and robots, but many of the intelligent systems controlling the next generation of those products may come from outside the country. Noetra is an attempt to change that balance. At the center of the project is an enormous AI computing facility powered by Nvidia's next-generation Vera Rubin platform. The planned system will contain 27,500 Rubin graphics processors and 13,750 Vera processors. The chips will be connected inside a massive AI factory designed to train foundation models for robotics and industrial automation. Construction is expected to begin in 2027, with the facility scheduled to start operating in 2028. Japan has already committed hundreds of billions of yen to the program, while potential public and private investment could eventually reach around 1 trillion yen. This is not simply another data center designed to run a chatbot. The system is being built for physical AI. A language model learns patterns from text. It predicts which words should come next and uses those patterns to answer questions, write documents, or generate computer code. A physical AI model must understand something much more complicated. It needs to understand gravity, friction, balance, distance, force, and motion. It must recognize that a glass can break, that a wet floor can be slippery, and that moving machinery can injure someone. It must distinguish between picking up a soft towel and lifting a heavy metal component. It must understand how objects look from different angles and predict what will happen after a robot touches them. A robot operating in a controlled factory can follow a fixed sequence of programmed movements. The same arm repeats the same action thousands of times because the objects arrive in nearly identical positions. Physical AI is supposed to make robots more adaptable. Imagine a robot inside a warehouse where packages arrive in different shapes, weights, and conditions. Instead of following one rigid program, the robot examines each package, decides how to grip it, predicts how its weight might shift, and adjusts its movement in real time. Inside a nursing home, the challenge becomes even greater. A robot assisting an elderly person must respond carefully to unpredictable human movement. It needs to know when to support someone, how much force to apply, and when to stop. A small mistake in a digital conversation may produce an incorrect sentence. A small mistake by a physical robot could cause an injury. This is why training these systems requires enormous amounts of computation and data. Japan believes it has a major advantage in the data needed for physical AI. Its factories have decades of experience in precision manufacturing, industrial automation, automotive production, electronics, and robotics. Companies already collect information from cameras, sensors, production equipment, quality control systems, and robotic machinery. If that industrial knowledge can be combined into a shared foundation model, Japan could create an artificial intelligence system designed specifically for the physical world. That would give a Japanese automobile company, for example, access to a general robotic brain that could later be adapted for vehicle assembly. A shipbuilder could train the same underlying model for welding and inspection. A hospital could customize it for medical logistics, while a food company could use it for handling delicate ingredients. Instead of every company building its own AI system from the beginning, Noetra could provide a common foundation. The ambition extends far beyond a single model. Japan's government is targeting the deployment of 10 million AI-powered robots by 2040 across 18 sectors. These could include manufacturing, logistics, construction, agriculture, food production, healthcare, disaster response, and elder care. The motivation is partly economic, but it is also demographic. Japan has one of the world's oldest populations. As the workforce shrinks, many industries are struggling to find enough employees. The problem is especially visible in caregiving, construction, transportation, manufacturing, and rural services. Robots are not being presented only as replacements for workers. In many cases, officials hope they can perform jobs for which there may simply not be enough people. A machine might transport supplies through a hospital, reducing the time nurses spend moving equipment. A robot could inspect dangerous sections of a damaged building after an earthquake. Autonomous machines might handle heavy materials inside factories or help maintain infrastructure in areas with declining populations. Japan has promoted robotics for decades, but the global competition has changed. Traditional industrial robots were one of Japan's greatest strengths. Companies such as Fanuc, Yaskawa, Kawasaki, and others helped automate factories around the world. These machines were precise, reliable, and highly specialized. The new competition is about general-purpose intelligence. American companies dominate advanced AI chips, cloud computing, and frontier models. Chinese companies are rapidly producing humanoid robots, autonomous machines, and lower-cost hardware. Startups around the world are raising billions of dollars to build robots that can learn multiple tasks rather than repeat only one. Japan risks becoming the supplier of motors, sensors, and mechanical components while foreign companies control the intelligence inside the machines. Noetra is designed to prevent that outcome by creating national infrastructure that Japanese companies can use without handing all of their industrial data to foreign platforms. Data security is one of the project's strongest arguments. Factory data can reveal product designs, production methods, failure patterns, and confidential processes. Companies may hesitate to upload that information to an overseas AI provider. A domestic platform could allow Japanese businesses to train advanced models while keeping sensitive information within a trusted national ecosystem. But the project also reveals a contradiction. Japan wants greater technological independence, yet its national AI system will rely heavily on Nvidia's chips. The Rubin processors at the center of the project are designed by an American company and depend on a global semiconductor supply chain. Noetra may help Japan control its models and data, but it will not make the country completely independent. There are also practical risks. Large AI facilities consume enormous amounts of electricity. Building the infrastructure is expensive, and training a model does not guarantee that companies will successfully deploy it. Robots must become affordable, reliable, safe, and useful enough to justify replacing or assisting human workers. The target of 10 million robots is therefore not only a technical goal. It is an enormous economic and social experiment. Workers will need new training. Companies will have to redesign workplaces. Regulators must decide who is responsible when an autonomous machine makes a mistake. Hospitals and nursing homes will need strict safety standards. The public must be willing to accept machines operating around vulnerable people. Japan's advantage may not come from creating the most human-looking robot. It may come from building machines that quietly solve real problems. A robot does not need a face to carry supplies through a hospital. It does not need legs to move components across a factory. It does not need to imitate a person if wheels, arms, cameras, and specialized tools can perform the job more safely. The most important robots of the next decade may not look like science fiction characters. They may look like carts, cranes, machines, and mobile platforms, but with an AI system capable of seeing, reasoning, and adapting. Noetra represents Japan's attempt to connect its industrial past with an AI-driven future. The country that helped teach machines how to move now wants to teach them how to understand the world. It is spending billions on chips, models, data centers, and partnerships because it believes the next industrial revolution will not be controlled by the companies that build the strongest metal bodies. It will be controlled by whoever builds the intelligence inside them. By 2040, Japan wants 10 million AI robots operating across its economy. Whether it reaches that number remains uncertain. But the project shows how quickly the AI race is moving beyond screens and into the physical world. The next great AI platform may not live inside a phone or answer questions through a chatbot. It may stand beside workers, move through hospitals, enter disaster zones, build vehicles, and care for an aging population. And Japan believes this may be its last chance to build that future on its own terms.